Okay, I'm going to take the model we had before. I'm going to modify it. So it's currently not open because it crashed on me. Let me click open. And so this is what we had before. And if I go to the model keywords, here are the various keywords we have to run the model. And so what I want to do is I want to just change the shape of this particular problem to make sure that I run something that is no longer just a rectangle. In this case, I'm going to do a solid shell of TNT with an outer radius of, say, 4 centimeters and an inner radius of 3 centimeters, so uniform thickness of 1 centimeter. And here are the changes I need to make to the model to try that. And part of the reason to do a hemisphere like that is because meshing it is a lot harder, or maybe not a lot, but a little more difficult than a rectangle. And so we'll see why in just a second. But let me get rid of the part. So I want to get rid of part one, hit delete, and yes, let's really get rid of it. And so I'm going to create a new part first, and then I'm going to hook it back into our model. So let me go to Mesh, 2D Mesher, just like we've had before. Here we go. And let me start to create the part. And let's say I want the part to start at 0, 0 and sweep upward. So in that case, I want the 4 centimeter side to be at 0, 0 and the 3 centimeter side to be up 1 centimeter. So let me start putting in some points. If you end up not having, if you end up having geometry here, if you remember, I started from a window that was blank, so there's no geometry. Maybe you don't start from that. You start from your prior model. Just hit clear a few times. And so that'll get rid of all the prior geometry and all the prior points. So once again, let me hit the points. I'm going to key them in, and I want to point at 0, 0, create, and then a 4 centimeter radius hemisphere will have a point if I'm going to just make a hemisphere at 4, 4. So let me hit 4, 4. Let me hit create. Now I'm going to auto center so that it brings it in. And I only need 2 points to define that. I'll show you that in a second. But I need the inner radius. And like I said, it's going to be a centimeter thick and 3 centimeters. So I want to point here at x equals 0, y equals 1, and a point up here at about y equals 4, x equals 3. So let's make a couple points. X equals 3, y equals 4, create. There's that 1 point. And then I need one at x0, y1, create. And now those are my points I need. Let me go and open up the create a circular arc. I'm going to do a radius with 2 points. And let me do the outer. That's 4 centimeters. And so I'm going to pick that point and that point, and it's added it in. The inner, 3 centimeters. And oops, hang on. I messed that up. Let me hit delete because I crossed them. Hit that again. And create. I'm going to pick, oops, no, I want to pick those guys. And I want that point and that point. Whoa! I screwed that up because the radius is 3. So let me hit delete. And now create 4. And I need to pick that point and that point. There we go. Now we're moving forward. And the other one has a radius of 3. The inner points there and there. And let me close this out by just simply picking these points to close out our geometry. And I'll use that to create edges in a second. So here, let's create an edge. And I want 4 independent edges. So let me create that, that one, and finally the center. Create. And now I need to add in the number of elements along each side of it. The challenge for a circle ends up being is that the radius of this, the length of that, is going to be different than this guy. And that makes it a little bit harder to mesh. It's not clear how to do it. So for this, I want the same number of points here as I want out here. And that means that we're going to have four-sided zones, but they'll be a little bit narrower in here, and they'll be a little bigger out here. But that's one of the easiest ways to mesh a relatively thin shell. So let me go number of elements. This goes from 0 to 90. And so the easiest way to think about the elements is maybe in degrees. And so if I wanted every 1 degree, that'd be 90 elements. But that's a little high. Let's make it every 2 degrees. So that's going to be 45 elements. So let me click 45. I'm going to click here. Now, if I want to make it an easy way to mesh the inner to the outer, I want the same number of inner elements as outer. So if I make that 45, it makes it easy to connect the every inner point to every outer point because there's the same number of points. So let me click on this line, and I've now defined 45 inner and outer elements. You can see these are going to be bigger on the outside than they are on the inside, but for the most part, that's going to be okay, and it makes meshing very easy. Now I need to figure out how many elements I want along these edges, and I don't really know, so let's start with something silly, and let's try 3. That's not going to be enough points, but let's click and see what they look like. And so this is how big they are, and I want them to be about roughly that size. So let me increase the edge elements to the 6 and see. That's a little better. Maybe they match the outer a little better, but not quite the inner. Um, and so a lot of times I'm playing around, and I'm going to pick 10 here. Let's see. That's not too bad. So I'm going to leave it at 10 for the inner, and I'm going to leave it here for the outer, and I'm going to now have enclosed my 4 sides of my geometry, and that's going to make meshing very easily. So let me go over here and click on Create a Mesh. And here I can create a quad mesh because I have the same number of elements here and here and here and here. So that makes meshing very easy. I can click that guy. And if I click just one side, I get the elements. I'm going to click Accept and Exit, and this is my new part. So I'm going to blow this up. Now I need to modify everything so that it uses part. Let's make a few changes. I didn't tell it what the part name was, so let me go here, click on that, right click, rename. I'm going to call it TNT again. TNT. And I need to make a couple of changes to the keywords. Let's pull that up. And the 2 changes I have to make. One, the part was deleted, and I added a new part. So I need to make sure that I update the part. The other thing is that the initial. This is the detonation light location, and earlier it was at I think y equals 0, x equal to 1, which is probably in space. I don't know where that is. So I'm going to move it so that it's largely kind of here at 0, 0. So let me open that up. Part ID, if the part ID had changed from 1 to something else, I need to change it. Let's see. Part ID is still 1. When you did this, if your part ID changed, change that to the right part ID. I'm going to leave it the same. Here I want X to not be 1. I want it to be largely 0, Y0, Z0. To make this to ensure that the light point is actually inside this element, sometimes when you put 0, 0, 0, it can be outside. I'm going to make it very, very slightly inside. So let's add a couple of zeros and a 1 there for both the X and the Y, just to make sure it's inside the element. And that's just for our sake to make sure that the model doesn't say like, hey, there's no HE here. So let me click, I clicked accept, done. That's now in the element. The other thing is I've got to modify part. Our part is what the geometry looks like, and it is what is the material, what is the EOS, what is the section going to behave as. And if I open this up and look, because we've deleted it, our section is no longer defined, our material is not defined, EOS is not defined, hourglass isn't defined. So Let's add those back in. And title's fine. TNT is okay. Section ID. So I want a 2D shell, material ID, TNT, and EOS ID. So these are all in the model currently. I just need to assign it to this particular part. Let me hit accept and done. And the final thing before running, because I played around with the section, sometimes the section was Cartesian, sometimes it was axisymmetric, and I don't remember what it is. So let's look. It's 13. If we go down here, 13 is plane strain XY. That's Cartesian. I want it to be axisymmetric. I don't want these points to actually blow into here. I want it to be basically a shell rotated about this axis here. And so that's actually going to be 15. So let's change that to 15. Accept, done. And now let me run the part. I think everything's done. We changed the initiation point to be here. We changed it to be axisymmetric, and we assigned the part. So File, Run LS-DYNA, and hit that. There's already geometry in here. It's going to overwrite our original rectangular part. Maybe I should have changed the name, but it's okay. And so the part ran all the way to 20 microseconds. And it says it's got a normal termination. So let's see what happens. Hit LS pre-post. Oh, and I forgot to save the thing. God darn it. Well, that's good because I can save keyword as, and let's call it Hemi. Now let me run it. Yeah, I was surprised it finished. It's going to crash. I can almost promise. Okay, it's running. Let's see what we get. Error. That's what I thought. And if we look up here, it's going along 15, 15.9, 16.2, and then it says negative volume. And what it means is one of these, let me close this out, one of these elements here turned over and is kind of inverting its geometry. So let's look at it. And this is kind of a complex geometry to run. So I sort of knew it was going to die. Let me pull this down and let me go all the way to the end. And let's look what's going on. Well, okay, you can see right here there's kind of a weird line with some stuff. So we've got this part of the geometry piercing into this part of the geometry. Let me go back a couple. Right, you can see that happening right here. As it comes up, this slides in, and now we have a negative geometry. And so this is one of the challenges to running explosives. It's kind of hard to run. It likes to do things like this. But let's look very quickly at the pressures. It ran almost the entire time, so we can still get some interesting information out of it. Let's go stress, pressure. Let me go all the way back to the beginning and hit play. And we see it's detonating and sliding along the outer edge. Our boundary in the center, our axisymmetric boundary, is keeping anything from going over into negative R space. Here are the pressures. And then what you're going to see is this is going to slide into this part and it's going to die. And so that's one of the challenges to running these HE models, is trying to get it to run to completion and not have situations where the geometry becomes negative. And we'll cover how to deal with that in later tutorials. But for now, try and put in all kinds of different geometries and see what happens and see how far you can get your model to run before it ends up crashing. All right, good luck.